All right, let's do this. This is homework number 2 for chapter 3. Looks like we have 3 to work on tonight. Let's see, determine which transformation was used on each pair of polygons below. Some may have undergone more than one transformation, but try to name a single transformation if possible. All right, so A, if we're just doing one transformation, it's going to be reflection across. Right? If we take this, and reflection is basically just a flip. We flip it across. Let's group it together. And we flip it across. Okay. It would actually end up right there. So A would be reflection across that line, right? The line of symmetry. So I would say reflection across the line of symmetry. Okay, this one right here. This is just simply a translation, right? You can translate it to the right, and then you can translate it up. So that's 2 translations, or you can just translate it diagonally, right? But usually that's a little harder. So you say this is a translation to the right and translation up. Or you can say translation up and then translation to the right. Either way works. So I would say this one is translation right. And since it's not on a graph, we can't say, 3 units or 2 units. So we'll just say translation right and then translation again up. And again, it's not on a graph, so we can't say, up 2 units or 1 unit or whatever. All right, this one right here. To get it to match, we have to rotate this around a point, right? And we can pick a point anywhere we want. Let's say about, let's do simple. Let's do two transformations, right? So let's say first is a rotation, and then a translation to the right. See how that works? Okay. So first I did rotation. Oops. First I did rotation, right? So I just took that and rotate it. And then next I did a translation. See how it lines up? So this one, we would call this a rotation counterclockwise. We'll call it CCW for counterclockwise. And then we would translate to the right. Okay, this one right here. I say we just do a rotation. Let's say we rotated down at this point right here. Okay, I'm just picking a point. So rotate around that point right there. I'm going to go ahead and group that together. And so if we rotate it about that much, maybe a little bit more. Yep. So we just say rotation around that point, that rotation point. Okay, or you could do rotation, or if you don't want to say that, if you don't want to say that, you can just say, oops, you can say this is a rotation clockwise, and then a translation to the right. So you can do 2, or you can say a rotation around that point, and we can give it a name, point P or something. Okay, and I just kind of picked that point, but it actually worked out pretty good. So I'll say rotation clockwise CW around point P. Right? And if you want to do the second one that I mentioned, you can say rotation counterclockwise and then translation to the right. Okay, this one right here, I think we can do a reflection across this line right here. So if I take that and I reflect, which is basically a flip across that line, I'll end up over here. So I'll just say reflection across your line of symmetry. Okay, this one right here, F. It's definitely a rotation, so you can take this and rotate it. This one's a little easier, 90 degrees. And if you translate it, you see how it doesn't work, it doesn't fit. Okay, so rotate it 9 degrees, and then you have to do a reflection across that. So take that, and then if I flip it left and right. Oh, hello, what happened? Oh, sorry about that. Flip it like that. I'll go over there. Okay. Press the wrong reflection. So I'll say rotation clockwise 90 degrees. This one's a little easier to tell. Some of the other ones we were just kind of eyeballing it, and then you can do a reflection across your line of symmetry. Okay, that red line. Okay. 20. Jamila wants to play a game called Guess My Line. She gives the following hints. Okay, 2 points on my line are 1, 1, and 2, 4. What's the slope of her line? Wow, some kind of game, huh? So if you have the point, these 2 points, and you want to find the slope, okay, you can graph it. That's the hint. Graph of the line may help, but you can use the y's, 4 minus 1. So we can say the slope is equal to 4 minus 1 over 2 minus 1. Okay, that's going to give us 3 over 1, or the slope is 3. What's the y-intercept of the line? Okay, so to find the y-intercept, you can do the y equals mx plus b, because you're looking for the b. All right, so if the m is 3, the x, there's 2 points. Use either one. I'm going to go ahead and use, I feel like using the 2, 4. Right, you can use 1 and 1. That's actually probably easier, but if I use 2 for x and 4 for y, okay, that's going to equal 3 times 2 plus b. 3 times 2 is 6. So that's 4 equals 6 plus b. Take away 6 from both sides. 4 minus 6, and you get b is equal to negative 2. So what's the y-intercept of the line? B equals negative 2. What's the equation of her line? Her equation is y equals m, which is the 3. So 3x, and then plus a negative 2, plus b, which is the negative 2. Right, you see how you have a plus 3 and then a negative 2? You can put it together, and you can just write it as minus 2. Okay, let's look at the last one. Determine the domain and range of each of the following graphs. So you look at each of these. Notice how this has an arrow. It means it's going to keep going down and also to the right. See how this one, it kind of just keeps going up, but then it follows that line. So if we, and somebody was telling me about the highlighting method, but if we were to do the domain is how far left can we go. And see how this keeps going left? So that means that there's no boundary. It just keeps going in that direction. And how far right do we go? Well, it keeps going right as well. So it's going to keep going left, and it's going to keep going right. So the domain is all x's that are greater than negative infinity and less than infinity. The range are all y's, and you got to look at the y's. So how far does it go on the y? Right, well, you see the down arrow? That means it's going to keep going down. It's going to go as far down as we can see, which is negative infinity. So y's are greater than negative infinity. But how high up does it go? Well, it's only going to go up to that point. It doesn't go any higher. You see how it kind of just follows that? So that's the highest it goes, which is number 1. So the y is going to be less than 1. And it's not equal to it because it'll actually never touch 1. It'll just keep following that line at y equals 1. Okay, so let's go ahead and finish this off. So the second one, we're going to go ahead and so I'm tracing over this graph, which has a start at this point right here, and it just keeps going to the right. Right, so if we're going to be doing our domain, okay, it's going to be all x's, right, and then it's going to be x's that are greater than what? So what's the smallest x? And x is along here. So look at the x, right? So what's the furthest you can go? Well, this is as far as we can go, which is that yellow line, and that x is going to be -3. And you see that blue dot right there at -3? That means we actually go to -3. So we're going to go ahead and say x, which is greater than or equal, because we actually do touch -3. So x is greater than or equal to -3. And then you see the right arrow, it's going to keep going to the right. So that means it's going to keep going in this direction for the x. Right? And that is going to be your infinity. So x is going to be less than infinity. Okay, make sure your x is in the middle between those two numbers. Okay, your y, or your range is going to be all y's, right? And if you want to set up, it's always going to be less than symbol and the less than symbol. And what's the lowest you can go on the y? So again, here's your y, right? This is your y-axis. What's the lowest you can go? Right, well, the lowest is -2. You see how that point right there ends at -2? Right, it actually ends at -2. So you're going to go and say it's going to be equal to -2. So it's going to be y, which is greater than or equal to -2. And how high does it go? Well, that arrow keeps going up, up, up. So that means that it's going to go all the way to infinity. Right? Okay, see? So look at that. Has a double arrow going down. It's going to look like that. Okay, so the domain is x in the middle. You can do less than symbol and less than symbol like that. And then you're going to start with what's the furthest left you can go. Well, you see the arrow? It's going to keep going down and diagonally to the right or to the left. So that means it's going to keep going to the left. And you see this arrow right here? It's going to keep going down and diagonally to the right. So it's going to keep going to the left. It's going to keep going to the right, which are where the negative infinity and positive infinities are. Okay. And then in terms of how far down does it go, it's going to keep going down. So on the y, it's going to keep going all the way down, which means that your range is going to be all y's, for which it's going to be greater than negative infinity, because it's going to go all the way negative infinity. And then how high does it go? And it doesn't keep going. It kind of keeps going up, 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 and then it stops right there. You see that? It doesn't go any higher than that point right there. So the highest it goes is 0. So it'll be y is greater than 0, and actually does stop at 0. So we're going to put a little underline right there. Okay, and the last one, we'll do orange. Here's your graph. Has an arrow going to the left and up, and then it has a no corner, and then it has an arrow going to the right and up. Okay, so for your domain, how far on your x, how far does it go? Well, it's going to keep going in that direction, which means it's going to keep going to the left. So that means it's going to be negative infinity, and it has this arrow right here, which means it's going to keep going to the right, which means positive infinity. So your domain is going to be all x's, which is greater than negative infinity and less than infinity. Okay, the range, it's going to be all y's. Let's do less than symbol. And then since we're talking about range, we're talking about y's. So how low to how high? And we want to start from least to greatest. So how low to how high? And those arrows right there can tell you that it's going to keep going up and up, but it doesn't actually keep going down. You see at the lowest you can go on the y. Okay, look at the lowest number. The smallest number you can go on the y is right there, -1, right? Because it does end right there. So it does go -1, and the double arrows keep going up, so it's going to keep going to infinity. So our range is going to be as low as -1, and actually does touch -1, so we want to put a little underline for the it's being equal to -1, and does keep going to infinity, which it doesn't touch infinity, so we don't put an underline. All right. Okay, and that's our assignment. I don't think there's a back side, is there? No, there is not. All right.